Consider the function f from R to R, f of x equal to x plus sin x, x belongs to R. Option A. The function is strictly increasing at every point on R except at x equal to an odd multiple of pi, where the derivative of f is 0 and where the function f is not strictly increasing. Option B. The function is bounded in every bounded interval but unbounded on the whole real line. The graph of the function y equal to f of x lies in the first and third quadrants only. D. The graph of the function y equal to f of x cuts the line y equal to x at infinitely many points. Okay, from 2009 this question is there, and this is a multiple select question, so more than one option could be correct. Okay, so obviously first let us write down the domain, the codomain and the definition. Okay, look, I know that sine of x will always be between -1 and +1, correct? Sine of x will always be between -1 and +1, and therefore I can say that x minus 1 will always be less than or equal to x plus sine x, and x plus sine x in turn will be less than or equal to x plus 1. Have you got this? Got it? Hope you understood
Yes,
that.
sir.
Yes. Okay. Now look, what are y equal to x minus 1 and y equal to x plus 1? They are two parallel lines. Okay, they are two parallel lines, correct? So our graph is sandwiched between the two. Therefore our graph is sandwiched between the two. Now this will help us in recognizing the validity of option B. Okay, I'll come to that later, but first let us look for option D. Okay, option D. Now look, whenever sin x is 0, okay, when sin x is 0, I can say that f of x is equal to x. Yes, and this is true for all x which are integral multiples of pi. So the graph is going to cut the line y equal to x at infinitely many points. We actually know them, where x is n pi and y will also be n pi. So option D is correct. Okay, option D is correct. Okay, fine. Now what are we going to do? Let's come to option A now. The function is strictly increasing. The function is strictly increasing. Is it true? What is the derivative of the function? The derivative of the function is 1 plus cos x. Correct, because the function itself is x plus sin x. Okay. Now, if you want this to be greater than 0, because we want it to be strictly increasing, not just increasing. Strictly means equal to 0 is not allowed. Okay, if we want it to be that, then what should we have? We have cos x greater than -1. Correct. Now if you want cos x to be not to be equal to its minimum value, which happens at pi, 3 pi, 5 pi, 7 pi and that, so x can't be an odd multiple of pi. Okay, x cannot be an odd multiple of pi. Now let us read option A. They say function is strictly increasing at every point in R except at x equal to an odd multiple of pi. That, at least that part is true, where the function's derivative is 0, true, and where the function is not strictly increasing. Yes, that's true, because the derivative is 0 that tells us that the function momentarily becomes flat there. Okay, like an inflection point. Okay, so option A is option A correct? Yes, option A is correct. Okay, option A is correct. Okay. Okay, now let us come to B and let's make use of the text that we have written in the blue color. The function is bounded in every bounded interval but unbounded on the whole real line. That's true. Okay, that is true. Now how are we going to justify that? Okay, so because of this, I can say that given an interval AB, okay, given an interval AB, what can we say given an interval AB? Okay, the value of the function will never exceed B plus 1 and will never fall below A minus 1. Raise your hands if you have understood this. Right, so exactly, so is it true that it is bounded on every interval? Yes, it's bounded in every interval. But is it unbounded on the whole real line? That means can we come up with a number? All values of f of x are less than that? No. As range of f of x or as range of x is negative infinity to positive infinity, range of x plus sin x is also negative infinity to positive infinity. Right? So is it true that it is unbounded? Yes. Therefore unbounded on R. That is, no real number m belonging to R exists such that mod of f of x is less than m for all x. Okay, no such R exists. So B is true. B is true. Now what about C? C says the graph of the function lies in the first and the third quadrants only. Now this is something that we need to worth. Take a look. Okay. The graph of y equal to f of x lies in the first and third quadrants only. Okay, look. See, this is y equal to 1. We can say this is y equal to 1 and this is y equal to negative 1. Okay. And suppose let us say this is pi by 2 and let us say this is negative pi by 2. Okay. Now look, for all x, okay, for all x in the interval 0 to pi by 2, okay, in the interval 0 to pi by 2, x is positive and sin x is also positive. Correct? For all values of x in the interval 0 to pi by 2, x is positive and sin x is also positive. Therefore, x plus sin x will automatically become positive. Okay, so both the graphs of y equal to x, okay, the graphs of y equal to x and y equal to sin x, okay, they are positive, and from now on there is no looking back because x is going to dominate, right? So I can say if x is greater than pi by 2, which is eventually greater than 1, x plus sin x will always be greater than 1. Okay, or you can even come up with a more or a tighter bound, but that's not it. So we've got it. Okay, so if you follow this, And if you use the fact that x and sin x are odd, okay, f of negative x is negative f of x, and therefore it lies entirely in the first and the third quadrants. Okay, understood. So all options are correct. For question 5, all options A, B, C and D are correct. Any doubt? Shall I explain it again?
No doubt, sir.
No? Let's check it here. Let's check it here. First, the two lines x minus 1, x plus 1. Our graph will be sandwiched between the two. That's true, and you can see that it's clearly in the third quadrant and first. Lastly, let's go for y equal to x. It cuts this line at infinitely many points. Now let us take the derivative and see whether it is at what points, when does it ever become negative. It doesn't ever become negative. Where does it become 0? It becomes 0 at all odd multiples of pi. Our answer is correct. Okay, our answer is correct.